again, but.
All right, so Foundations of Math 20, this is Chapter 6 mid-unit review. This is kind of 6.1 to 6.3. 6.4 to 6.6 continues on a little bit with this idea, but it gets a little bit more tricky. So this is grouped together for a reason. We're talking about inequalities, talking about graphing inequalities, and then 6.3 we're talking more about systems of inequalities and finding solutions where we have more than one inequality that we can draw. Okay, so mid-chapter review, so 6.1, when graphing an inequality, what process should we use? So first of all, I guess we'll need to properly scale the graph, determine how much of the graph we're going to be using, what your numbers are going to be, what the ranges are. Determine the boundary is first main thing. So plot the line that is associated with the inequality. So just replace the inequality sign with an equal sign, and that's your boundary line. Again, I'm not going to read every word here. I'm just going to talk about what we've done, and I'll show the details on the screen if you want to read them. But the boundary line is important. Find out where the points that are part of the solution, which again are going to be a range of values, like a whole bunch of values, where the boundary line is that they can't cross. So we draw the line. If it's or equal to, like these right here, then the line is solid. If it's not or equal to like this, the line is dashed. Okay, and it can be a dotted line if we know that the values are discrete, like if they're whole numbers or integers only, then you can put like the dots on the line if you want. All right, so then what we'll do is we pick a point on one side of the boundary line or the other. Usually 0, 0 is a good one. Unless the line goes through 0, 0, then it's not a good one to check. But if you check 0, 0, and when you plug x equals 0 and y equals 0 into the inequality, then you can easily see whether the inequality is true or not. If it's true, then 0, 0 is part of the solution set, and you shade that side of the line. If it's not true, then you shade the opposite side of the line. Okay, again, this is just review. I'm not going to do any demonstrations here right now. Now, when using graphing technology, we haven't really used graphing technology with this. It might come before the end of the chapter. We'll probably use the graphing calculators a little bit, but I won't talk about this really right just yet. But we can sketch some lines on the graphing calculator, which will help us form our graph. Okay, so let's see, what does this talk about? Okay, just remember there's a difference between, shading fully the regions and drawing just the points for whole numbers or natural numbers. So if we're talking about number of people, then obviously we can't have small portions of people to count them as a person. So we have to have whole numbers only there. And if we're talking about, amounts or quantities, volumes, we can have all sorts of little decimals. So that's, we can shade the regions fully. And for a system, the solutions for the system are where the the shaded region that's overlapping both inequalities, that's the solution. So because this region over here on the left is the solution region for both inequalities, that's the solution for the entire system, which is the two inequalities at once. Okay, so that's just a bit of review. What I'd like to do is let's go over a question here. Let's see, we could do number 6. I don't know. Number 4 and number 6 are pretty much the same. Let's do number 4, 6.2, number 4 from the mid-unit review. Okay. Okay, so let's take a look at this question here. It says, Nick is preparing a tomato and red pepper soup as the daily special for his restaurant. All right. To allow the red pepper's taste to dominate, he will have at least twice as many peppers as tomatoes by mass. Okay. So twice as many peppers as tomatoes. However, he wants no more than 25 kilograms of tomatoes and red peppers altogether. Okay, so I'll use blue for this one. No more than 25 kilograms of tomatoes and red peppers altogether. So again, we're not counting peppers. It's all kind of by mass. This is all mass. Okay. So define the variables and write a system of inequalities. So we're looking for a system here. Defining the variables is something we have to do first as well. And then B says graph the system. Use your graph to suggest 3 possible combinations of tomatoes and peppers according to this. Okay. Now you could just trial and error, randomly guess, and just see if they work with this information, because this is not a hard problem. It's kind of an easy problem. But we're going to follow the directions. We're going to define our variables. We're going to write a system. We're going to graph it. And we're going to look to see what possible combinations we could use for this. So we're going to do it all from scratch, like exactly the way we're supposed to. Okay. So to allow the red pepper taste to dominate, we have to have at least twice as many peppers as tomatoes. Now remember we talked yesterday about this, that this is a tricky one, at least twice as many. So not always should you just go, oh, twice as many peppers, that's 2p, okay? Remember, you got to be careful there, right? So first of all, let's do p is peppers. That makes sense. So we're defining the variables here for a. And T is tomatoes, okay? Tomatoes. So those are our variables. And let's now create a system. So remember, twice as many peppers as tomatoes. So that means that the number of peppers has to be at least, so equal to twice the number of tomatoes, to let the peppers dominate. So we are not going to do 2p. Okay, so if we did 2p, okay, versus tomatoes, okay, so that means that the tomato mass is equal to 2 times the pepper mass, or the pepper mass is half of the tomatoes. See, that doesn't make sense, right? So we're going to want to put the 2 over here so that the pepper mass, okay, is at least equal to, so I'm going to put the equal sign there for now, is at least equal to 2 times the mass of the tomatoes. Does that make sense? I like writing an equation first, like pepper mass is equal to 2 times the tomato mass. Now, the peppers can be more than twice, right? Because it says at least twice as many peppers. So the pepper mass could be more than 2 times. So if this can be more over here, then I will put, looks like a greater sign there. Does that make sense? So tell me if that fits with this first bullet here. Do you think that makes sense? Do you like that? Or is there a problem there? Let's read it one more time. So the peppers, at least twice as many peppers by mass as tomatoes. So the peppers are going to be greater than or equal to 2 times the tomato mass. Look, that's awesome. That means the pepper mass is greater than the tomatoes because we've doubled the smaller mass. You see? It's another way to think of it. You double the smaller one. Okay, all right. Let's do blue and let's do the next one. So he wants to have no more than 25 kilograms of tomatoes and red peppers altogether. That one's a super easy one, right? It's like peppers plus tomatoes. Now, no more means that 25 is the max. The maximum. Does that make sense? So P plus T has to be a less than or equal to 25. The 25 has to be the biggest compared to these guys. So no more than 25. That means that 25 is the max. So the peppers and tomatoes have to be less than or equal to 25. Thumbs up? Yes? Good so far. Any questions? Okay, no questions about those two? That should be pretty easy. Awesome. Okay, let's graph the system. So we're going to take these two inequalities and we're going to graph them now. So let's do that. I'm going to move this up out of the way a little bit. Okay, so let's put the graph down here. I'll make it in red. Does it make sense to have a negative number of tomatoes and a negative number of peppers? No, we can't have a negative mass. So I'm just going to do the positive axes for the X and Y here. Now let's label this, what do you want to do? You want to do peppers down here and tomatoes up here? I don't know. You think? Doesn't really matter. Just pick one. It doesn't really matter. If someone else reverses those, and your graph will look a little different, but the combinations will still be, should still be the same. Everything should still work. Okay, so I'm just going to do it this way. All right. So I want to do the boundary now. So I want to take a look at what does P plus T equals 25? Okay, what does that look like? Well, if we do a little table of values here, okay, P and T, and I've encouraged you to do a table of values to show your reasoning. So if P was 0, then T would be 25, right? If P was 25, then T would be 0. Those are two good ones. The intercepts are perfect. All you need is 2 points. That's all you need. You could put 12 and 13 if you want. You could put 20 and 5 if you want. Doesn't matter. They will all line up on the same line. So I'm going to put 25 here. I'm going to put 25 here. And I'm going to draw a line. Now, it's or equal to, right? So I'm going to make that line a solid line. And we are talking about mass. So for mass, will the peppers and tomatoes, they will be an element of what? Is that going to be whole numbers, natural numbers, or all real numbers? What do you think? Think about the nature of mass. Do we have to have whole numbers for when we're weighing something? No, we can have decimals, we can have fractions, anything. So guess what? That's going to be all real numbers. Mass is a continuum, okay? As detailed as your measurement instrument can go, that's how many decimal places you can have it. There's no limit to the number of decimal places you could have, only the instrument. So that means it's all real numbers. Okay. So 0, 0, if I plugged 0 in here and 0 in there, would that be less than or equal to 25? Is 0 less than 25? Yes. So that means that we would, and I'll shade this time. Sometimes I do the arrows on the line, but I'll shade. Just a rough shade there. Okay. So below. Awesome. Okay. So let's do the other one. And I'm going to zoom out just a little bit here so you have more on the screen. So let's do the other one too. I'll do that in black. So P equals 2T. Okay, so P and T. So if P was, I don't know, what do you want to say, 10? If P was 10, what is T? 2 times what is 10? 5? Huh? Is that okay? I'm doing P equals 2T.
I heard 2 times 10 is what, and then I heard 5.
Oh, 2 times what is 10? Yeah. Okay, so then if T, okay, let's say P is 0, what is T? 2 times what is 0? 0. Okay, so 0, 0 is on here. 10, 5 is on here. I mean, do we need another one? We don't really need another one. But what about, well, if we did the 25, that'd be a half a number. Okay, whatever, just doubles. So we could do 4 and 2, right? Okay, so let's go back to our graph. This is where you're going to have to try and be as accurate as possible, okay? Which might be a little tough, but 10 is going to be here, and 5, whoops, 10 is going to be here, and 5, 1/5 here, 1, 2, 3, 4, 1, 2, 3, 5, right about here, okay? That's 5. So 10 and 5 is here, 0 and 0 is here. If you have graph paper, all the better. Graph paper and a ruler would be best, okay? So you're going to draw a line through those 2 points, and it is or equal to, so solid line is totally fine. Okay, so it looks something like that so far. Now I need to check my actual inequality. So P is greater than 2T. So I can't pick 0, 0 because it's on the line. So the P is the X value, right? So if I chose a value like, well, let's say 20 and 2 is right here. So 20 for P is greater than or equal to 2 times 2 for T. Is this true or not? Is 20 greater than or equal to 4? Yes. So that means that I shade everything under this line. Okay. Any questions here so far? Because I'm zooming in on this graph here a little bit now. So the question says, use your graph to suggest 3 possible combinations of tomatoes and peppers. Okay? So we need to pick any possible combinations that would fall in this feasible region right here. Okay, where they both overlap. So we just picked one. We did 20 and 4, or 20 and 2, I mean. So you pick any 3 that are in here. So for B here, right? 20 peppers and 2 tomatoes. Okay, another one would be what? 5 and 1, something underneath here. 5 and 1, let's say. So 5 peppers and 1 tomato. So anything that's in there, you could actually go right on the line too, looks like. So we said this was 10 and 5. So 10 peppers and 5 tomatoes. That looks like it works. Okay, so any 3 that would be in this feasible region. All right. Okay, so some of you writing this down. This is, again, part of your assignment, so hope you're doing this with me. Any questions right now on this? Yes?
For like the P's, the element of real numbers,
Yeah.
let's say on a test, we have to write that as real numbers.
Okay, well, do you have to write this exactly? You can show me this by your shading, right? If you show that it's completely shaded, then that's fine. Sometimes though, like in the textbook, they will shade even though we're talking about whole numbers, and they will just then highlight the intersection points of whole numbers. So you have to be very careful. This would be the best way to tell me that you understand the nature of the variables. So I would suggest that you remember to put that in there, as long as you can correctly convey that with your shading. So for example, if it was just whole numbers and you had a graph like this, okay, and you shaded this region, but it was only whole numbers, and you didn't clearly tell me that you're only looking for the points that would be on the intersections of the lines, right? So you'd have to communicate that somehow. Best way would be to kind of just state the nature of the variables. So yes, I would suggest that you do that to make sure that you communicate well. Okay, good. Any other questions? All right. That's number 4 from your mid-unit review. I would suggest you do number 6 as well on your mid-unit review. That one there you should be able to do on your own. They even give you, well, they kind of give you a start anyways on the on these. So you do have an assignment from 6.3 as well that you may not be finished, so you can work on this number 6 or finish your assignment right now. Okay, quiz coming up.
That was easy.
Wait, so is it like a whole assignment for this, or is it just like some points?